think you can all see my screen now. My name is Bryan Taylor, and I'm an engineer that works for Encore Electric Delivery. And I would just like to give you a short presentation on a cool project I've been able to be a part of, where we have started using drones and LiDAR to help keep Texas safe. So first of all, not all of you may know what Encore is. So Encore Electric Delivery is the largest electric utility in Texas. And we are the ones that deliver the electricity from the generation facilities to the businesses and houses all around Texas. So you can see a short little diagram down here of kind of what we do. So the generation stations, that can be things like coal power plants, nuclear power plants, or solar panels. So they are actually making the electricity, and we don't have anything to do with that. But after it goes through this transformer that I'm pointing to here, it takes that electricity and makes it really high voltage, and then it will go along the power lines. So my company owns all of the power lines pretty much in the area, and it'll take all that high voltage electricity, it'll go to a substation, which will turn down the voltage, and then that electricity will be carried on some smaller wires on wood poles to get all the way to the businesses and houses in the cities. So how does the power grid work? So electricity moves across high voltage lines on giant lattice towers. So on the far left, you can see what these lattice towers are. And then they will come to our substations, and then they'll be transformed into lower voltage and be carried on wood poles. And then I really like this picture on the right because it kind of explains what volts, current, and resistance are. So if you don't really understand it, I like to think of it as water going through a pipe. So the volt is like the pressure. The higher the voltage, the harder the electricity is being pushed down that line. So we want the really high voltage stuff to push the electricity for miles and miles across the country. And then whenever we get to the local cities and towns, we've got to step that down, because I don't think any of you want one of these big towers in your backyard. So that's why we need to step it down, and then we use the wood poles to get it to your house. So as an Encore engineer, this is some of the team that I work with. We took a group picture, and my goal in my job is to help design the system to be as safe and reliable as possible. So how do we keep people safe? Well, the main thing is that we, of course, design the power lines so the public doesn't come into contact with them or with the energized equipment. And we also want to teach the public about all the hazards of electricity. So like I was saying, with high voltage, the voltage can actually get up to over 700,000 volts on our high voltage lines. And by comparison, what you probably are using in your house is like 120 volts. So over 6,000 times higher voltage. And as you can see on this left picture, this is what's called an electric arc. So whenever you get to that really high voltage, you don't have to touch the power lines directly. They can actually arc quite a distance. So you want to stay as far away as possible. So we try to keep our lines where no one's going to get within about 25 feet of those high voltage lines, and then about 10 feet of our lower voltage lines. So on to the project. So the project I'm working on is specifically dealing with lakes. So we want to make sure that there aren't going to be any sailboats that are getting anywhere near our power lines if we have power lines going over a lake. And the way that we're doing that is we're using drones. So some of you may have some toy drones that you've played with before, or maybe your parents have a drone. But drones are able to fly around with cameras and other equipment to take pictures and get some precise measurements for where our power lines are. So this is just a picture of what one of these drones might look like. So in my job, we have other people that are licensed to fly these go out and take a video. So I'll just play that really quick. So this is one of the videos I received. It helps me, instead of having to drive out to the location and take a lot of different measurements, instead they're able to fly their drone around and they're able to take a video for me so I know exactly what's going on out there. And then I think the even cooler technology is something called LiDAR. So most of you have probably heard of things like sonar. So sonar is what, say, bats use to be able to know what's around them. They'll send out sound waves, and based on what they hear from the sound reflecting back, then they know what their surroundings look like. Radar is similar, but it uses radio waves, and the radio waves will reflect back to let you know exactly what's around you. Well, LiDAR uses light. So these drones will actually have lasers, and as they're flying along these lines, these lasers are shining light onto like our power lines, and depending on how long it takes to reflect back, they can know exactly how far away that power line is. And so they take thousands and thousands of little measurements. So this is just an example of what that might look like. These are all just a bunch of little dots that it's hard to tell unless you zoom in, but it's thousands and thousands of measurements that it's able to take. And so on the right, this is an example of what I get to look at. So after we get all that LiDAR data, we can put it into a different program. And so this will plot out every little point that it measured. So we have the actual power lines here. And like I said, if you zoom in, you can actually see that it's just thousands of little dots that are taking all these measurements. So instead of me having to go out and try to measure it myself, that's what these drones are able to help me do. And really the goal, like I said, for this project is we don't want any kind of sailboats getting anywhere close to our lines. As if a sailboat hits our power line, that could be really bad. And so after we get this data, there are some other things to consider. So just because a power line looks like this on that day doesn't mean it can't sag down lower. So for example, the power lines will sag down lower if it's hot. And so we can take everything we know about the line. We can take what kind of material it is. We can take what the temperature is. And we're able to figure out, okay, if it's on a really hot day, then instead of being in its original position, it's going to look like this new position. And so then our software lets us calculate just how high up is that, and then we'll say that hey, there's a chance that a sailboat could hit this, and so I would then let the designers know, and we'd be able to fix that line and make sure that everybody stays safe and that the power lines are high enough off the ground. So just some things I always have to consider in my job. What is the power line crossing? So depending on what it's crossing, we might need to be up higher or down lower. So if it's crossing a road, then we're worried about trucks maybe hitting it. Lakes, we're worried about sailboats. And then buildings, we just want things to be far enough away from buildings where no one could potentially, reach out and touch it, or the power lines aren't going to hit against the building. Because not only could that cause a power outage, but it could also hurt somebody. What kind of power line is used? So we call our power lines conductors, but depending on how much electricity is going through, we might have a really big wire or a really small wire. So we want to take that into consideration. What is the temperature of the line? So of course, if it gets hotter, like I said, then the line is going to sag down lower. So we need to be aware of how hot it is, and then how long has it been installed. is over the first few months of that line being out there, it will do something called deform, and it'll start to sag down a little bit lower until it's fully deformed. And